again concave mirror. Principal axis, pole of the mirror, center of curvature, principal focus. The object is at the position C. AB is the object. We know the point B, image of point B lies anywhere on the principal axis because it is lying on the line which is normal to the mirror surface at point C. Now, first ray we consider is parallel to the principal axis. It will be reflected along the direction principal focus. Another ray, let us consider passing through the principal focus, incident ray, and is reflected in a direction parallel to the principal axis. And we shall find that the direction the image is formed at the same position C. So A dash becomes C, where the two reflected rays meet. So this is the incident ray in first case, this is the reflected ray. This is the incident ray in second ray, and this is the reflected ray. These two are meeting at common point, and that point becomes the image of point A. That is called A dash. Draw perpendicular, and where it touches the principal axis, that becomes the image of point B dash. And you will find that the object is formed at the same position where the image is formed at the same position where the object is placed. So what we observed from this image formation, number one, the position of the image at the center of curvature, the size of the image. The size will be same size as the object. Size will be equal to the size of the object. Third, nature will be real because rays are actually meeting, and inverted, and you can see it is inverted. So this is what we observe. Okay, the other case, and the object is between center of curvature and the principal focus. So what we are doing is bringing the object closer to the surface of the mirror. So we had brought it at C, center of curvature. Let us bring it a little more closer. That is between C and F. Object between the center of curvature and principal focus. That is between C and F. The concave mirror. Principal axis. Center of curvature. Principal focus. And somewhere in between there is an object at some position between C and F. So AB is the object now. So a ray, let us consider one ray parallel to the principal axis, and now we know that it is reflected to the principal focus. So direction of reflected ray is along the such that it is passing from the principal focus. Okay. Now we can consider one more ray. We can consider a ray which is oblique, which is making some angle with the principal axis and incident at the pole. So this is the incident ray, and we know that it will make equal angle as the angle of incidence and will be reflected and this angle and this angle. These two angles are equal. This is angle I, this is angle R. So this is the reflected ray, and we see that these two rays meet at one point. So this point becomes the image of point A dash. Draw a perpendicular on the principal axis, and this becomes B dash and an arrow at A dash. So this A dash B dash is the image of point of the object AB. Now you see that this image is formed. This image is formed beyond center of curvature. So it is formed beyond center of curvature. Also, you can see the image is real and inverted, and also the size of the image is enlarged. So we can conclude from it this position is beyond center of curvature. Size enlarged. And third, that is the image nature of the image is real and inverted. Okay. Now, after this, we can consider another case where the object is placed at the principal focus. Let us bring the object even closer at the principal focus. Object at the principal focus, that is F of the mirror. So let us draw again the mirror. The principal axis, pole, center of curvature, principal focus, and the object is at F. Object AB at the principal focus. So let us consider a ray parallel to the principal axis once again. And we know this ray passes from the principal focus after reflection. So this is the reflected ray. Okay. Another ray we can consider is passing from the center of curvature. So let us, it is incident in such a way that seems to be it is passing from the principal focus also. So this is the ray. So this is the ray which is incident, and it will be reflected back along the same direction. So along the same direction it is reflected back. So this is the ray which is incident, and this is reflected back along the same direction. We extend it further to see whether the two rays are meeting at any point or not. And you will see that the two rays are parallel to each other. So when they are parallel to each other, they never meet. Parallel lines, we know that, never meet. So these rays will never meet at one point. So therefore, when they are parallel, they meet at infinity. So what we get is when they meet at, they are supposed to be meeting at infinity. So when they are meeting, that means the nature of the image is real and inverted, and it is highly enlarged because at infinity the image will be very, very large. Position where the image is formed is at infinity. And size highly enlarged, and nature real and inverted. So if you place a screen very far away from the mirror, you will find an image which will be much larger than the size of the object. So this is the fifth case. So number 6, the object between the principal focus and pole of the mirror. Let us draw the figure. Pole, this is say F, this is C. Okay. So object is between F and P, somewhere here. So AB is the object lying between P and F. Now, image is to get the image. Let us consider a K ray which is parallel to principal axis. When a ray is parallel to principal axis, after deflection, it passes from the principal focus. So this is a reflected ray. Okay. Now we can consider one more ray which is incident obliquely at the mirror. Let us say at P, it is incident at angle I. So this is the incident ray. And it will be reflected making an equal angle. So these two angles are equal. And this is the reflected ray. And this is the reflected ray in first ray. So these are two reflected rays, and you see that the distance between the two is increasing as you go further. That means these rays will never actually meet at any point. So image formed will not be real and inverted. But if you extend it in the backward direction, these two rays, they seem to be meeting at one point or originating from that one point. That one point becomes the image of point A. To draw perpendicular from A on the principal axis, and A dash B dash becomes the image. Now you see that the rays are not actually meeting, but seem to be meeting at A dash or seem to be originating from A dash. So that means the image of A, that is A dash, is the virtual image of point A of the object. It is not the real image. And you see that it is inverted with the object. It is erect. So what we infer from this, what is the result? The position of the image. You can see it is behind the mirror. It is behind the mirror. So position is behind the mirror, on the other side of the mirror. And the second is the size. You can see the size is larger than the object. So enlarged. And third, nature. Nature is because it is not actually meeting, it is virtual and erect. So this is what we get from the sixth case, that is the object is lying between principal focus and pole of the mirror. And this image cannot be taken on the screen. It can only be seen in the mirror, and the image is found behind the mirror. Like our image, when we see the plane mirror in front of us, we see our image. So that kind of image is formed. Applications or uses of concave mirror. So it is used as a reflector. Used as a reflector. And where it is used as a reflector? In the headlight, motor headlight. Searchlight. Torch. So it is used as a reflector in all these different types of appliances. So how it does it? So it is placed at the, it is fixed in the headlight in such a way, or torch in such a way, that the bulb is placed at the principal focus. So this is the principal axis, and this is supposed the principal focus. So bulb is placed at this position. The electric bulb is placed at this position, and the rays of light from principal focus are incident at different angles at the surface of the mirror, like this. This is the incident ray. And we know when the ray is passing, incident ray is passing from the principal focus, it is reflected along the direction parallel to the principal axis. So this is the reflected ray. So you will get rays which are reflected rays which are parallel to the principal axis. So you get a beam of light, parallel beam of light, so which goes very far away, and you can see the object in front of you. Okay, so we get a parallel beam of light which illuminates the road ahead of the vehicle. So that is why it is used as a reflector for the headlight. Second, it is used as a shaving or makeup mirror. So shaving or makeup mirror is a mirror when the object placed very close to concave mirror. We know that this, in this case, object is placed close to the mirror, that is between pole and principal focus. Then the image formed is virtual, erect, and behind the image, like the image we see in plane mirror of our face that we see in plane mirror. The image is erect also, it is enlarged also. So because it is erect and enlarged, we can see a bigger image of our face. So when we see the bigger image of our face, we can check we can use it as a makeup or shaving mirror. Okay, so in this case, the face of the person is close to the mirror, and he sees or she sees a larger image of it himself or herself. And third is in solar cookers. We use in solar cookers. These are cookers which are used to cook food using the light from the sun. Now again, here the mirror collects a lot of light and reflects it on a small region, and it helps in cooking the food. So what happens in this case? It is reverse of this. Here again the mirror. We know the rays of sun are coming from infinity. So when these rays are coming from infinity, so the rays are parallel to each other and parallel to principal axis. When these are incident at the surface of the mirror, then what happens? After reflection, all the rays which are incident on the surface are reflected along the direction such that it passes from the principal focus. So all the rays pass from the principal focus. So all the energy of all the rays is concentrated at one point. Okay, and this point, because the energy is concentrated, the temperature becomes very high. And if we place the cooker box at this position, all the energy is received by the food which is placed inside the cooker box. And that is how we are able to cook food using the energy from the sun. Okay. Another application is in hospitals. In hospitals, the concave mirrors are used by dentists. And also by the eye, nose specialists, ENT specialists, eye, nose, and throat. Now, these are used to focus light on the different parts of our body, like on a teeth, nose, eye, and throat, to examine these organs. So here the mirror is used like this, such that there is a bulb which is at the principal focus of the mirror. No, rather, this is a case. This is a case where the light is falling on the surface of the mirror, and all the light is being reflected at single point F. So this at F, if your tooth is lying at the principal focus of the mirror, then the light coming from the bulb will be concentrated at your tooth, and the dentist will be able to see their tooth very clearly. So it is used in hospitals also. So we have already discussed the image formation by concave mirror. Now we shall discuss the image formation by convex mirror. So we'll find that the convex mirror always produces images which are virtual. So wherever you place the object in front of the mirror, the image formed is virtual only. That is virtual and erect. So let us consider the object placed in one case at infinity, and in the second case somewhere between infinity and pole of the convex mirror. The first case, object between infinity and pole of the mirror. Okay, so let us see what the case this is on the mirror now, and this is the principal axis. Okay, so infinity is very far away from the surface of the mirror, reflecting surface of the mirror. Let us see. Let us say that the object is placed at this position. A, B is the object, and now let us consider a ray which is parallel to the principal axis. Here it is, and this is the center of curvature, and this is the focus. So we know after the equation, the ray either passes from the principal focus or it appears to be passing from the principal focus. It will be reflected in this direction. So extended backwards, it seems to be originating from, or seems to be passing from the principal focus. So this is the incident ray, this is the reflected ray, and seems to be passing from the principal focus. Okay. Now another ray that is considered is incident at the pole at some angle. So this is the incident ray, will be reflected making the equal angle. This is angle I, this is angle R, and we see that the ray, when we extend it backwards, it seems to be originating from a point. We have extended, so these two rays, both these rays seem to be meeting at this point. Okay, so this point becomes the virtual image of point A dash. Draw perpendicular. So A dash, D dash is the virtual image of the object AB. And these two rays, because these two rays, both the reflected rays seem to be originating or seems to be meeting at this point A dash. So what kind of image we get? The position of the image. The position is between pole and the principal focus, between P and F. The size of the object. The size of the object is smaller or diminished. And third, the nature. Nature is virtual and erect. Okay, so this is what we get from this image formed between P and F, and the object is lying between infinity and pole of the mirror. Now we shall discuss the case where the object is lying at the infinity.